Hello, my name is Matthew Van Bommel, and I'm an undergraduate student studying mathematics and statistics at Acadia University. This video will serve as an introduction to my research on stage-wise surrogate modeling of tidal power functions. The Bay of Fundy, located between Nova Scotia and New Brunswick, has the world's highest tides, with a difference in water level between low tide and high tide of as much as 17 meters. This results in huge amounts of water flowing through the bay. In the Minas Passage, a narrow part of the bay, the flows are especially high, with water speeds exceeding 5 meters per second. Because of these physical properties, there is considerable energy in the tides, and thus there is significant potential for extracting tidal power through the use of in-stream turbines placed in the Minas Passage. An important problem is determining the optimal location of these turbines to generate the most power. Physical experimentation, such as placing actual turbines in the passage, is not a cost-effective approach to determining optimal locations. There exist deterministic numerical models, or computer simulators, that are able to calculate potential power, averaged over time, at any given location. These simulators can also model the placement of virtual turbines, and after each placement, a new simulator is generated, which includes the effects of the turbines. And while this is a significant improvement over physical experimentation, these simulators are still computationally expensive. To further reduce computation cost, statistical models, such as Gaussian process models, also known as GP models, can be used as effective surrogate models to approximate the computer simulators. However, even with GP models, after each turbine is placed, the new simulator must be modeled, and each model requires computations of the computer simulator. It can be noticed that a placed turbine only affects a localized area around it, rather than affecting the entire region. Thus, to further save on computation cost, I have adapted the GP model to allow it to model a local effect, and have developed a stage-wise surrogate modeling approach which only models a localized area around each additional turbine, and then combines this model with previous information to save on computation cost. This approach is what I would like to present at the SSC Student Conference, along with details of the adapted GP model and some preliminary results. I would like to acknowledge the following for their contributions to this project. And finally, I have included some reference for this video abstract. Thank you for listening to this brief introduction of my project.